Hello. We'll give it a few minutes before we start. We will see. How are things, everybody? All right. Okay. What's going on, everybody? Oh, look at all the no check-ins. Oh my gosh. I want to check in, and I can't check in with all these no check-ins. I am bad at programming. Well, that's not necessarily as true as it used to be. So, where is this? This is emit struct dereference new. This is struct dereference small. Pills here. Okay. So here we go. Uh-oh. There's still a no check-in. How would I miss it? Let's test the LLVMs again. Just to be sure. We tested them before on the last stream, but we're going to test them now. What do the tests look like generally? They're just code. They don't tests don't matter that much. Like, I mean, they're important to, it's important to test your software, but we have this weird culture of people obsessing about tests in ways that doesn't make sense. Your software is the product. Your tests are not the product. We could also see what our frame rate is. It's probably still low 18 like it's been. But it'd just be good to review that. There are definitely some things we could do to the x64 generation that I think would help with the frame rate significantly, but they would not show up in the Weissman score unless we change our definition of the Weissman score, which we will do later when we focus on those things. Driving cars by pushing them with guardrails. That is an apt description. Yes. Like, you could probably make your car go a little bit that way. Yes. Have I messed around with industry simulation software? Not really. I don't know much about the field, really. Oh, God, don't start saying FPS. Like, don't bother. I just need to ban everyone from chat. No, 18 frames. Fuck you if you don't understand what I'm talking about. Jesus. Okay. I'm already starting off very annoyed. Yeah, so we're sort of low to mid 18. It's about the same as it was, which is good. We don't want any surprises there. So that's good. All right. So I think we have one more. Well, let's do the check-in. It's like people just keep saying snobby stuff about the same issues that, like, it requires no effort on somebody's part to say that they don't like a number that I'm talking about, right? It's like, I've been working on this thing for 6 years, and there are good reasons why the numbers are what they are. And like, oh, somebody was in chat for 10 minutes and doesn't like a number. It's just like, why do I do this? Why do I do it? It doesn't make sense. Why don't I just lock myself in a room? Oh, hey, man. Hello, Raiders. Hello, Raiders. You never heard of FPS as a measurement? What? Okay. Why am I here? Okay. So, I have a list of other fun things to try for gains, but wow, the morning stream ended up being a bug slog, and then I did a bunch of bug slog off the stream, but everything is fixed as far as I know. There's probably still other mistakes, but we'll see. But we're down here at this last case is the one that we are not correctly doing. And then really there's a bunch of cleanup. Like, we might not do more Weissman score for a little bit because we still have old struct dereference to like replace and stuff. Anyway, so here, if it's a big value, we want to do what did we do up here? We get so this is big with no value number. So we do the following. We get the register. We, instead of segment load plus offset, we want to do segment Lee plus offset, but we don't have that yet. But we can make it happen. We're going to say offset in O. Just like segment load plus offset. In fact, we should probably change that to segment load. But let's just do it here. So we're going to go Lee with the base allocation and the offset. All right. So then what? We're just returning the R value. So like, I think that's literally it. Except with the finished plug register. And we say, is that really all? Yeah, because I guess if you do the assignment, so we have find or emit Lee. But we want it to work first, and then we can switch to that. Dude, it's not like, it's 18 frames per second. In debug x64 code, which is not, I'm not going to explain again. Never mind. It's like, it's not because it's in development software. Although there's that too. It's like 7 different factors on top of each other, which is why I get so annoyed when people ask about it. It's like we're making our own engine in our own programming language with that back end, like squeezing the machine instructions out with our own bare hands. Like, it's a miracle it goes 18 FPS under those conditions. Like, are you kidding me? It's an astonishing amount of work to get that far. All right. So it's not even that that level doesn't even run at 18 FPS, guys. Look, I'm going to sit here and do a release build of the game, and you can see that it runs faster than, it's like, see, it's so silly of me to spend time explaining it because 10 minutes later, somebody new comes into the stream and says, why is the frame rate low? And it's like, oh my God. I'm in an extra bad mood because it was just a really sloggy day. That's all. Twitch ad mid-rant. That makes rants even better. I need to put in the fake FPS count. But the point is, I am actually using that FPS to gauge progress on the x64 debug build backend. Add a fact to my Twitch page. Yeah, I don't. Maybe. I just can't. Nobody would read it anyway. LLVM, sure. Oh, I did this with the debug compiler accidentally. It's probably going to take 10 years. LLVM is so slow in debug compiler. All right, we're going to try again on release, and this will merely take less than 1 minute. Unless I broke something. That would actually be good to know because we haven't run the release compiler in a little bit. Uh-oh, guys. This might not even run because I did this. Okay, hold on. Hold on. Because I did this. So hold the horses. Actually, it's a really good sign that the compile time execution got as far as it did. Because like to even get to where it says running 2 user code hooks, compile time execution does a ton of work. And that all worked with this new code switched on. So that's promising. Yeah, with regard to putting more of a page on Twitch, so the past week or so, I've just been withdrawing more and more from the modern consumer internet. And it's very good. So like, I don't want to put more work into like a page to make Jeff Amazon more money, right? Like, especially when every time I go to Twitch, Jeff Amazon puts me on a shitty rave music channel. Like, come on, dude. Okay, here's the same level. It's like 40, 38, 39 in release build on an in-progress game engine with 4,000 entities in the level. So it's like we're doing fine. Although after I opened the editor, it frame locked at 30. I think we turned on VSync when the editor opened or something. But the point being, the 18 FPS is the debug build, guys. It's like criticizing, yeah. All right. It wasn't really criticizing anyway, but it's set off. It's a sore spot with me. All right. So now that we're back on debug build, we could try building the compiler at debug build and get a mere 18 frames per second on that level. 60 on other levels. All right. So it built all the way. We got a slightly but not much better Weissman score. Oh, a few hundred. That's good. That's gains. Let's do it a few times. See what happens. It's just a little bit under our old Weissman score. Let's see if it runs. All right. Let's verify that runs on the tests. And if it does, then we get a little more Weissman score. And then I have to clean up the yucky perf part. And then maybe we could move on to a different oh, no, because I want to start cleaning up the other thing. Okay, so this is good. Let's just mark this incomplete. Using find or emit Lee actually might give us a significant Weissman boost. So let's check this in. Okay. Now, I'm actually surprised that it hasn't been a lot bigger. I wonder if there's something malfunctioning here. Maybe we got most of the Weissman boost yesterday from this. All right, so let me try using find or emit Lee. It's going to take an offset from the linear allocation. Wait, guys. I didn't go through and make the offset work anywhere. Which means that just nobody happens to be exercising this, which is bad news bears. We're going to have to do that. Have I just been spending less time on the internet in general? Yes. Yes, I have. But also, the internet has just become a very low quality place lately. It didn't used to be as bad as it is, believe it or not. Yeah, I'd argue it's been bad for years. 2020 really put it way over the top for me, and it just got too dumb to participate in, but it's been bad for years. Okay. So this is not good that we're not exercising this. Wait, how come all these people don't use find or emit Lee? Like what? I kind of don't understand. Oh, we have to put the... Okay. Hey, guess what? We have this now. Let me put that on my gains list. That'll be a good one. All right. All right. Okay, so here, there we go. Okay. I'm just going to do one more pass over. Just going to make sure we set that. Options, 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 options. We use a non-zero offset in exactly one case. That's fine though. Optimizer will probably be able to use it. Okay. Find or emit what? Oh, offset, not options. Offset is argument 3. Like we literally don't use it. Boomp diddly oomp. Boomp diddly oomp. That's great. Let's try the LLVM because we just can always do that. We can also build the game over here. Make sure that runs. See our Weissman score, 353108. Shouldn't really be different. Yeah. Game runs. That's great. So I'm tempted to, well, all right. So we're going to check this in. Then we're going to deal with yucky perf, which actually is easy now. I thought it was going to be really annoying. Turns out it was easy. Is it okay to ask questions about other topics? Right now, yes. Like sometimes if I'm concentrating really intensely, then that's not good. But actually, we're on the back end of doing a bunch of intense stuff earlier today. So I'm kind of just chilling right now. Although we might get intense again later. We'll see. Didn't I build the release compiler? Yes. Good point. Good point. I keep doing that today. Today has been the day of building the wrong compiler. I'm just going to make sure they all work for now. I want to at least run in debug on x64 because I want to try the asserts out as well. But if it doesn't assert on x64, it shouldn't assert on LLVM. How long have I been on this build of Sokoban? Since we started measuring Weissman scores, like 3 days ago or whatever. Okay. We're going to run the tests with our actual x64, and then we're going to compile the game. Sorry, with x64 debug. Just again to scan for assertions. If I failed to set the options when we do a Lee, well, it shouldn't run, first of all. But also we should see an assert. Is there anything worth using C++ 17 or 20? Not that I know of. No. I mean, I sort of stopped at 11. Maybe there's a very tiny bit of 14 that I use, but you got me. I don't even remember. C++ is basically completely off the rails at this point. I mean, let's face it, C++ has a very bad Weissman score. All right, so what even did we do after all that testing? I don't even know. We made Lee takes an offset, struct dereference now handles all with new code for our value anyway. Okay. So now the thing is, we have this old code. Oh, let's do yucky perf. So I think if I just change this to local array, I'm probably happy with it for now. So what local array is it has, it's a stupid version of array that just has like 5 slots or something allocated by default. So it does no allocation whatsoever until you fill more than 5 things, and it's only going to be a very pathological expression that does 5 things in that loop. So I'm okay with that for now. I mean, I probably want to go simplify that later, but okay. So now we want to get rid of the old array code or old struct dereference code, because our compiler has a lot of lines. We want to get rid of some lines. So emit cast. So can we just change this to new? Oh, actually, let's see. I have a cleanup note here. Yeah. Okay, we're just going to pass binary, right? We'll deal with that later. That one's a little confusing. These are all for usings. Wait, this is emit struct dereference itself. This is also emit struct dereference itself. Emit declaration imported by using. Emit L value calls us. So we want to be able to handle L values as well. Let's try this. Let's actually hold off on this. Let's just do this change. And then we don't really need a site, do we? Because we know what the frickin' site is, guys. It's the binary. All right. So that's great. Release. Release. Did we get to pass that LLVM sadness from earlier? We did. We did. We are past most of the sadness now. There were several sadnesses. Oh my goodness, there were so many sadnesses. Okay. So this appears to have worked. So now I can go to the no check-in where we want to go to emit struct dereference new with binary. And, well, I have to untangle all this crazy L value, R value stuff. All right. So like this code, for example, is... Oh, no, it's not copied from there. It's copied from somewhere. Maybe this one? Yeah. Okay. So I'm just sort of copying what I wrote a long time ago. Oh. That's gross. Okay, return R value register. Okay, so Why can't I just, okay, I'm going to paste this in for now, but emit copy to produce L value, question mark. I believe we could do that. Okay. And then we had some other factor for emit struct dereference down here. Okay, so can I just do this? No, clearly not. That's convenient. Okay. That's convenient. I mean, do we dare believe that that will work? Maybe. Probably not. Okay. We're doing good. I don't think we dare do. Let's do release. We're living on the edge. Oh yeah, we lived off the edge. We lived over the edge. We lived between the edge. Oh. Right. There's another difference with R value. Okay. The type of the thing changes. debug. SA is 2. Shouldn't happen. Oh. Yeah, this is not how that works. This is not how this instruction works. We want this one. Add to constant value number, offset result. All right, well, Sokoban goes, but Arrays doesn't go. Okay, cannot take the address of the data field of a fixed array. That doesn't sound right. You know, I think when I said L value strict, that was wrong. Let's see. Let me look at the old version of the code. This one? No. Value type. Okay, so I did it wrong. We want to pass value type through. I knew it. All right. Yeah, obviously. Obviously. That's the sound of things going. Really, something awful forums is good now. I'm not that surprised. Is Rome going to fall this decade? No, I mean, not in an obvious fashion. I mean, dude, we have mutant coronaviruses that are apparently highly infectious now. And there's been a vaccine actually for almost a year, although nobody will admit that. And like, nobody but Israel is vaccinating their population. Like, how much more evidence do you need that everything is completely broken? Like, literally, Israel is the only nation on planet Earth that is handling the situation. Actually, there's a few other ones. It's just the other competent nations don't have enough coronavirus to worry about it. So like Singapore and maybe New Zealand. New Zealand might have just lucked out by being far away from everything. But like for them, like a vaccination drive is more dangerous because if you have so little coronavirus, side effects of the vaccine may be worse, right? But for most nations, let's put it this way. We are revealing that 99% of the population of Earth lives in nations with incompetent governments. They needed to test the vaccine. No, not really, actually. Like, if you actually talk to people, it's like everyone knew it would work. So you're like, well, what if, what if it has side effects or something? Well, it's like, well, because you were worried about maybe it has side effects, you killed millions of people who were in a high-risk group. Congratulations. It's like not good decision making. They had the vaccine on day 2. Yeah, it was very soon. It was very soon that a vaccine was made. And like, yeah, you probably should test it to make sure it works, but given the stakes, it should have been tested like the guy tested stomach ulcers, right? It's like, take someone who's not that high risk, give them the vaccine, get them very, very exposed to COVID. Do that with like 500 volunteers, which you easily could have found. You could have done the study in like 3 weeks on whether the vaccine was effective. So it's just embarrassing. That's really not how medical trials go and should go. Congratulations, you just killed millions of people, by the way. It's the idea of how medical trials should go that has killed millions of people in the year 2020. Millions haven't... What are you talking about? Millions haven't died. It's 300,000 in the United States alone. Now that there are so many strains mutating, will vaccination even work? I have heard people say that supposedly the vaccines should mostly work, but that was on previous strains. Like, apparently strains are popping up all over the place, and who knows, right? But like, we should have had this handled. This should have been over, in by the end of the summer. It should have been over. So like, we shouldn't have had all these mutant variants. All right. Let's get back to programming. Let's get back. Okay, so this is working, which is great. I didn't necessarily expect it to work, but it did. We might actually have slightly better Weissman score. Let's just test release build real fast. And check the Weissman score. It's probably still not much better, but wait, it got worse. We've had a Weissman decline. Oh no. Well, we're just going to have a momentary Weissman decline till we figure it out. Okay. Okay, I think I want to check this in, and then we'll try to figure out later why the Weissman score got worse. But right now, I need to just get the code mess cleaned up. That'll be very satisfying, actually. Okay, actually, this part here is probably... Oh, let's just do it. You make copy to produce L value. And that's the one that we're going to come do some Weissman score attack on anyway. Okay, so like we do a placement or not, we do a Lee, and then we do a store and a plug. Okay, so produce L value, R value, register. Yeah, this is general pointer. And that gives us a placement, which we didn't have. So let's try that. That'll give us a little bit of code gains. I ran the wrong compiler. I was like, that's taken slower than the release compiler should go. All right. Hey, cool. I'm just going to run the tests in release and then in debug once. But that's good. So we got some code gains, I think. And we're going to get a lot more code gains. We're going to try to get under 55K lines again. I don't know if we'll manage that, but okay. So the thing about flu in 2020 is everybody was social distancing. So you would expect flu transmissibility to be dramatically lower than it would be under normal circumstances. Our Weissman score went up again. Dang it. Wait, no, it shouldn't have. It's in the 354s. Life is hard. Okay. It might be that the placement is generating extra instructions, but that's something we can look into later. We could always just turn that off in cases where it's pathological. That's easy. Okay, so we're going to check this in. Remove one call to emit to old struct dereference. And I don't think we're that far from doing the new one either. Okay. Am I going to book my negative gains? I guess I have to. It pains me. I mean, we're still positive on the day, but yeah. Oh my gosh. All right, it's fine. It's fine. We'll get it back. I just committed, right? Okay. So the thing is, You know what? We didn't even finish this. This frickin' this frickin' dereference chain stuff, we're not even using it. We like used it to go to down here. Oh no, we did. Oh, I did. I forgot. So we have to test dereference chain. So that'll be fun. We'll find out that that is potentially broken. Yeah, I've been manually doing the Weissman scores. So I just have this in OBS and I can click on there and I can change my Weissman score manually. So the problem that I have about the COVID handling, right? On the one hand, like this time last year or a little later, like at the end of summer last year, I was thinking like, wow, we really screwed that up. But at least we got some practice for next time when it's worse, and maybe that'll be good, right? Because our defenses got tested. But now, like, our defense has obviously failed, and we're still like fucking around, not doing anything. So, like, I think it might actually be negative. Like, what political bodies around the world might have learned is that they could totally screw this up and it's not that bad, right? So why fix anything? Like, I mean, look at California and the vaccine. Like, that's exactly what's going on. So the problem is next time, if we do have a virus that's much more deadly, we'll have governments that didn't learn from this one. So good thing my girlfriend has a New Zealand passport. I mean, that doesn't help me very much, but she can get away, so it's fine. Yeah, I guess if I marry her, I can go to New Zealand, right? I don't know what their policy is. Okay. So there is, as far as I know, one more incoming. There are a number of calls to old emit struct dereference, but they're almost all from old emit struct dereference. So like that is, yep, that's in, that's in, that's in, that's in. Yeah. Oh, see, this is weird because this is like redundant with this other thing. Anyway. Yeah. I don't know what the deal is there. But these both kind of want the same overload. They want like a scope entry, the L value register, and the value type. Problem is, that's not exactly what we have. But so I'm thinking maybe I want to restructure the other loop back away from the way that it was. Like basically, I want a binary operation where this is the left and this is the right. The something like this. Can I funnel the cast via using to I mean, I kind of just want to put it here. So that's a declaration. And imported by. Okay. We're going to try this. We're going to assert that that's an asked using and I mean, no, this is stupid. This is stupid because yeah, it's not worth it. So basically, I need something that takes these arguments. And the thing is, this way of like passing the struct register, like this is defeating our whole reason of factoring things the way that we did. So we kind of want to say, here's the struct, here's the dealio. So really my instinct of not passing binary to here was correct. So I want to restructure this thing so it doesn't need a binary, right? Let's try this. Okay, before I do anything, let's make sure we still frickin' run, because I've just been moving my cursor around and doing, I don't even know what's going on. Okay, great. Just making sure. We even built the right compiler. Okay, so if I go here, I actually want this to be asked expression left, asked expression right, and cite, just like I had it originally. Okay, so instead of looping with binary here, we're just gonna do this. Left and right are our loopy loops. Okay, and then down here, like that's simple, right? We just change our thing. I like that better. That looks better to my eye. Oh, hold on. So binary. Okay, great. So we should just be able to go binary left, binary right, binary. Okay. Yes. Okay. That doesn't matter. I'm very inconsistent about cite. Sometimes it's an asked, sometimes it's an asked expression. Okay. If that works, I will do one more factor and then check it in. I don't see why it wouldn't work. Well, I do see why it wouldn't work. Let's be clear. I do screw things up all the time. Okay, so that's good. So now the last factor is we're going to make a thing called emit struct dereference new part 2. I think. Let's see. Do we even need left here? Oh, we do. Like, we actually want to bubble this all the way up here. Yeah. So we're going to make a different overload for this. We're going to do these preliminaries. This is all fine. And then we're going to do part 2. We're going to go emit struct dereference new part 2. This is going to be binary left. So this is all like defense against user level stuff. Left, right. Binary value type placement. Okay. We're going to put a site here. Should Okay. So get offset of legit struct reference. Member defin, treat as big argument, and go. And this all makes sense, and it's all actual work. I like that. I like this. I like this, what I am seeing here. Okay. Site. Okay. If that passes, we will do more factor. This still isn't affecting our Weissman score at all, hopefully. Just going to do a little debug on Sokoban. See how it's going. Okay, very good. Refactor, emit struct dereference new. That wasn't even very painful. Now, the part 2, part 2 might get factored into frickin' part 3. Hold on. So now the problem is we need this part actually this part we need get offset of legit. Oh, actually no, we might be good. We might be good. So so we could put this up here. This is a little dangerous, but we're going to do it. Yeah, okay. So this is going to be emit struct dereference new part 2 cast expression cast via using cast R value and placement. Now the problem is this thing on the right so I keep wanting to type 2020. Entry. I think that's it. There. I don't know. So I'm going to run this in debug again to try to catch asserts, but this is very promising that this just, oh, Oh, guys, we're running the wrong compiler. Sometimes it's too good to be true. Or sometimes it still works anyway. We'll even run LLVM at the end because it is pickier about casts. Okay. Okay. So we just have one more. The one at the bottom. This is still, yeah. Like, I really hope no other file somehow. It wouldn't make sense. Nobody else has any mitstruct dereference. Who are you kidding? Okay. So, this one is going to be new part 2. Entry import link. Struct register. Okay, we need... That's weird that we're doing the import link. But anyway, oh yeah, okay. So we're going to move this up to here because we can do that. I'm going to delete this comment because it's so old I don't care. And then, because we're doing something different now. Fuck. Yeah, whatever. Okay. Oh, you know what? Yeah. Okay, this is the part that's scary. Okay. It's a bit of a yucky hack. I don't know, guys. Emit scope entry eval. What? Emit. Oh, it's not on the. Okay. 2783. So this struct register stuff is no longer relevant. Expression. Oh, we need a site. It's probably not a very good site. All right, Weissman score is going down slightly again. And the Codesman score actually let's not risk a comment. I believe all this goes away. Does it blend? What exactly is the site? The site is just, it's one of the syntax tree nodes, and it's just the thing, if there's a problem, it's the thing that we use to report error messages to the user. Like we tell them that part of the code, right? So not all functions take that, but a lot of the non-trivial functions do. And if they give an error, then that's where the error is. Okay. I mean, that was successful, I guess. If we build here, that makes me happy. Where are we at in the Codesman score? Ooh, we're still over 5. Wait, really? Oh, because the if-def didn't count. Okay. So now we chop this. I don't think it's going to be enough, but like somehow our code got big. Our code got, yeah, see, we're over 55, but I don't know, it's less sane, or it's more sane now. I don't like being over 55. I can't drive 55. We're like somehow 100 lines over. Why? Why? It might be that, well, we did add more instruction power recently. So let's get rid of this ugliness. Get rid of this ugliness. And so the long-term project of improving the sanity of bytecode builder is, it's improving. So emit struct dereference used to be this very scary recursive function, and it's not recursive at all anymore, which is good. Anytime you can get rid of recursion, that's actually not that bad. All right, let's do LLVM test. See if it's picky. While that's going, we could do our Weissman score. Three, 5, 4, 5, 4, 5. 3, 5, 4, 5, 4, 5. I think that's about what we have, right? Let me see. That's a little better than what we have. All right, so we still took a little bit of a backslide in the Weissman score, but This is great because when things started going badly during this morning stream, they didn't go badly, but we had enemies on several fronts at once. I said, hey, if I can get to this point by the end of the night where the old struct reference is removed from the code, I will be happy with that. And we did get to that point. Now, there's a couple other things I want to do before we go looking for gains elsewhere. And that is, I want to make a little bit of test case to stress some of this new code a little bit more because I don't totally believe that it works. And it's quite likely that we might find bugs there. But yeah. Have the bytecode gains had any effect on LLVM speed? In principle, they should, but I haven't been measuring it. Probably more of an impact on the debug build speed, right? Release build just spends most of its time optimizing, and it probably gets a lot of these things early, right? So like most of the release build time is probably spent thinking harder, but the debug build time is probably roughly proportional to how much we throw at LLVM, right? So the fact that we are giving it, 20% less. Now, people out there in the beta could measure this if they want to verify that it's faster, but I believe hopefully it should be. Yeah. I've got my own Weissman score on my screen. Thought that it might also slow down the optimizer or throw it off. No, because it's really, we're not doing anything that would be hard for LLVM to understand. Like we're not packing things together in obscure ways to make it smaller. We're just like generating less dumb output. So it should be fine. I don't think we're doing anything that'll make LLVM do more work in any way. But again, like I haven't been measuring it in part because like there's just so much work to do, Yeah. But so in principle, there's nothing preventing me shipping the next beta now. It's just, it's so full of giant changes that it might be destabilizing. So maybe I need to throw people a bone and go back to the mailbag, which I haven't looked at in like a week, and fix some bugs. Because I'm sure there are bugs in the mailbag. But I've just been like working on this. Struct dereferences generate shorter sequences of instructions in many cases. This is actually okay. I'm very happy about all of this. This week has been great because of the following thing, right? This has been a very long project so far. It will continue, right? It's going to be long. It's going to be really long eventually, but it's been a long time, and I've been working on it for a long time. And of course, whenever I make something big, whether it's a game or this compiler or whatever, I have like a plan of what I'm doing, right? And I have like reasons why I'm doing things in the order that I'm doing. And a lot of those reasons have to do with like making the project tractable to do by a small team. A lot of them have to do with like, well, it's important to figure out this part of the language before putting a lot of effort into this other part or whatever, right? And so one of those things was like our own code quality was just like, well, we're deferring that until later, right? And along with that goes all sorts of things, like just having these data structures about basic blocks and stuff, right? And on the one hand, I have good reasons for all of that, right? On the other hand, there's always a little bit of nagging doubt whenever you have that, like, well, maybe we'll just never have optimized code because it's just too hard, and maybe we'll just rely on LLVM forever, even though I don't want to. Or, well, maybe when we start adding basic blocks and stuff to the code, it's going to add so much accounting that it'll slow things down, and that won't be worth it, right? or it'll kill debug builds or whatever. And we have enough of this in there that I can clearly see that none of that's going to be true. We can do, like, again, optimization, like generating faster output code can take an infinite amount of effort. It's as much as you want to work on making it better, right? But we are not actually that far from being able to just put in optimization passes and get the low-hanging fruit, right? And then once you have that, it's just like putting more work to do more passes, right? We're not that far. So there are certain things like the parameter passing for the language, the calling convention. I was like, well, this is to minimize aliasing problems. But we didn't have really a good way to see how much that minimizes aliasing problems because the compiler doesn't do data flow analysis, right? But it almost does now. And so we're actually not that far from being able to see the impact of some of these design decisions and therefore be able to tweak those design decisions to be better. So I am very happy. This morning's stream was a super slog, but I am very happy that we are at this point in where things are at. Okay, that is my executive summary. All right. Yeah, it really is like breaking through to a new. Now, all that said, I haven't done the stuff I was talking about during the stream in November about like doing the library stuff. And that stuff should probably happen too. It's just, I saw the opportunity to do this and really wanted to do it. So, yeah, these are gains. Will I expect a slowdown with optimizations? Yeah, I mean, making an optimized build is probably always going to take longer than a debug build, but there might be a very happy medium where it doesn't take much longer, but you get most of the speed. That's what I would like to find, right? So right now our game compiles in what, 0.65 seconds? Let's figure it out. Our 100,000 line Sokoban game, I have to take out the dumping because that's slowing it down a little bit. String to scale factor in load graph. All right. So right now, 0.65, 0.65, 0.65. Yeah, I'm looking at this number. So it's pretty consistent right now. So like, even if it was 50% more expensive to run a baseline optimized build, which is a lot, that's still a second, right? If in 1 second you can get pretty fast, that sounds great, and I think that that's feasible. Although I don't know. I mean, it has yet to be seen because we haven't put in optimizers and stuff. But I think it's feasible. Interesting to know how you do modules, especially with the run directive. Well, modules already can have run directives in them. Yeah. So like if we could do a release build for the Sokoban game in 1 second, that'll be pretty great. And again, keep in mind, this is not final, right? This is still like a factor of 5 to 7 off what I have pledged the final compiler speed to be. It may take a long time to get there because parallelism is hard sometimes, but it's doable. So then, like if I could make this 7 times faster, maybe the optimizer could run 7. Actually, the optimizer is much more embarrassingly parallel than the type checking. So we actually might be able to do a lot of optimization in 0.3 seconds. Because again, this is mostly using one core right here. Are there any kind of data flow analyses like unreachable dead code? I was maybe going to toy around with pruning dead procedures tonight to get a better Weissman score, but we might save that till tomorrow when I'm fresh. In principle, it should be pretty easy for us to notice when a function doesn't get called. For blocks inside functions, we don't quite do that yet. We do have a control flow graph at this point, but we don't really use it for anything. It's not really tested. So we don't like look at the control flow graph in any way and do things like that, like say, hey, is this block reachable? But we could do that eventually. If you can get rid of link, you already have a lot more time. Yeah, we just can't, for this game, we can't get rid of link because we compile against third-party commercial libraries, right? We might be able to like link all these stupid WWise libraries together and reduce the load on the linker. But like the linker is just slow. I don't know if that's worth it because it might save like 0.1 seconds, but it'll add a process complication. I've been threatening to rewrite the linker. No, I haven't. Somebody else might have said that. I haven't said that. I don't want to be in the business of writing a linker. No. That is not me. I think of linker as old, dead, inappropriate technology for this system. Any other on-topic questions before we go on? Did I check in? I don't think I did. So really, we did everything that I was hoping to do tonight. I want to test some of these things more thoroughly. And if they're broken, I'll be a little bit sad, but we could fix them. It's no big deal. This basic structure is sound and much better than what was there before. So if there are problems, the problems can be fixed, and they'll be easier than they would have been to fix the equivalent problems in the old system. Okay. Yeah, no, I don't like linkers. What's being worked on? The Weissman score is still being worked on. I rewrote the way struct dereferences are handled internally, and that it has just been completed. And now I was going to test it a little bit before I ship rickety stuff to y'all beta testers that doesn't work. Although that'll probably happen a little bit no matter what. So let's make a silly test case. We're going to go A is a struct, X is an int, I don't know, make that a float. B is a struct, Y is a float is 1, using A. C is a struct, name is a string, address is a string, using BB. Oh, this is going to be using B, pointer to B. D is a struct. F is main. T type is B. And using C is a C. And then E is a struct. I don't know. What's a good... T is type of... what's something? Type of procedure of call. Print high... using D as a pointer to D. Okay, so D is a D, E is an E, E dot D is star D, B is a B, E dot C, no, E dot B equals star B. This is a cool programming language, actually. All right. Who knows if that'll work, though? It might not be that cool. Oh, I need the hash. And this is like this. Okay. Redeclaration of T. Oh, yeah, because we had a T. TT. Okay. I kind of don't like... Oh, because print doesn't show usings. So I could say print e.x is whatever, e.x, print e.y is whatever, e.y. Okay. Yeah, I think that worked. %60 of the time, it works every time. Is an explicit goal to make the optimizing version of the compiler at comparable speed with debug build compiler. Well, I mean, what does optimizing version mean, right? Like, I think I think you could turn up the knob higher and higher and spend more and more time. But like, I would like, like I was saying, if this takes 0.6 seconds, then if I spend 1 second instead of 0.6 seconds, can I get kind of okay output code? And I think the answer should be yes. Like, that wouldn't be maybe full release build speed, but like, maybe it would be pretty fast, right? Like sometimes when you're doing 3D graphics, you're dealing with a lot of data. You really want some speed, right? So, and also maybe it'll still be pretty debuggable as well. I think that's the thing too, is make sure the release build stays pretty debuggable. All right. So that's one of the tests I wanted to do, guys, and it worked. The other one is make sure we're exercising all 4 cases. Which we certainly have at least 2, because we have big things and small things. This is so hard to think about. So we have value number versus versus not. So let's do a thing. Let's say report about E So that's definitely a value number situation. And then maybe I just paste these, because that's a stack situation. So 3, 1, hello. Okay. So let's put this in a buffer so we can see. Okay, so report about, oh no, main is first. Main is first. So when we get to, I mean, it's going to be weird to look at, oh, it's release build. Let's do debug. It's on my list to put more debug info in release, mode. All right, so when I go to line 51, we're calling print. So we leave the E. I don't know why we do that. Oh, because we never did. Wait, we have some gains. It's actually not about this, but I don't understand why we do a Lee there. In the stat case. The whole point, guys, the whole point of having this whole stat case is so that we can put these two instructions together. Add emitted string literal. Oh, wait. Yeah. Oh, guys, we're about to make gains right here. We are about to make gains. So instead of a Lee in a store, we do segment Wait, do we not have segment store plus offset? Okay, that's why we never changed this. We do not have a way to... So we have a store plus offset for a... Okay. We're going to make gains. This is going to be good. These are going to be good gains. It's going to take us a minute to get there, though. Because we have to... yeah. So load and store plus offset are variables. These are constants. Yes, okay. Well, we got to add some lines of code. Segment load plus offset. Segment store plus offset. Same thing, though. We want... Instead of like load address, we want store address. Oh, oh, no. We do this. Dest and reg. Like that. Okay. Store address there. Segment store, and then, okay, that's not, yes. All right. So we have segment load plus offset. Segment store plus offset. It's gonna, again, I don't know, let's just copy all this. I don't know what's going on. So we have a linear allocation. We have a segment index. We have an offset. If it's a stack, all right, we do a Lee. Okay, I think that's how we do it. And then okay, we already loaded it. So we need to store I need a size. Size, okay. We don't want move 64 indirect. We want like a move 60. Whatever. I don't care about code gen for this right now. So auto R0 is we need a free register. Get free int register mask. So we're going to 0. All right. I'm going to move 64 indirect. R0. base register is R, no, R dest. Offset is 0. And direction flag is into memory, and size is register size, register result. Okay. It's something like that, guys. I don't frickin' know. Rdest. Just delete these. These were dumb things that I did long ago. Okay. Okay, so we haven't done this in the LLVM backend yet. However, we do what line number was it in? 2 something? 223. No, in bytecode builder. Okay, so here now, instead of doing a li, we're going to do the following. Instruction. Bytecode segment store plus offset -1 count register count BC arrow big constant dot pointer equals SA. Count BC arrow offset is string count offset, and then set comment count BC string literal dot count. And then similarly, we do this for the data pointer. So instead of 1, 2, 3 instructions for every string literal, it's 2. And that is what we call gains. 2 instead of 3 is known as gains. String data offset, and then we need data register. Oh, actually, wait. Oh, it was 4. We're going to get... actually, I don't know. Hold on. Hold on, guys. We used to have constantly store. But there was a fifth one actually. It's four instead of five. It's not, it doesn't, not as good as it sounded, but okay, it's this one. So data register is assigned to string literal here. Okay. Okay. And then data register. Okay. Okay. 1, 2, 3. Yeah. Something like that. I don't know how to program, guys. Don't even. See, I think there's something called offset, which is obviously stupid. All right, well. Oh, we didn't update the bytecode names because this doesn't know how to print it, but it's also got the name wrong because we didn't static. I need to at some point static assert that these match because we're going to put other things besides names. Segment store plus constant, and then in printing, oh, plus offset. Wait, yeah. Segment load plus offset, segment store plus offset. Same deal, except backwards. All right, so okay. Here we go. Move stack plus 120. Okay. Move. See, we're going straight to the stack. It's readable. You could see what the hell is going on. We load V13 into the stack. Where's V13? 9. Oh, because it's the same length as the previous one, so we even saved that. So we get a 9, we put it in. We get a data pointer, we put it in. We dereference a couple things. I don't know what the hell's going on there. Anyway, let's just see if we can do the Sokoban. No. Let's double check our things. Probably was a stupid mistake, but was it segment store? No, segment store. Oh, you know, I didn't change the oh no. Segment store plus offset. So we set the options there, we set the options there. Okay. Let's just see what happens when we try to build. Okay, address CD, 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 C. The CDC is the official sponsor of this stream. Why are we at load plus offset? That's bullshit. We're loading a string data pointer that was probably stored by the other thing. store address. Segment store plus offset. Hey, look, I didn't add the thing. Are you kidding? Look at all the mistakes. Did we like literally never do a load plus offset? It's terrible. All right. I don't know what's going on. Let's just do this consistently. Offset is BC options. Offset. Offset. Our eyes can look for it and see it. Offset. Oofset. That's how I feel right now. Oofset. So we do these things. Address is now still CD, 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 D, 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 CD, D, 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 D. We can just dump whatever function this is in and make sure it looks right, although it probably does. I don't know. Things that don't use compile time execution seems to be going fine. So wait, this is load address. Now we want segment store plus offset. Well, I could probably print out. Let's just find out. So line 1055, probably in first. Yep. 1055. Oh, it's the wrong program. 1055. Okay. Oh my God, it's a Windows function call. Windows.invalid handle value null. Windows.page rewrite. Where is a string coming from here? Maybe it's not a string. No, but wait, it is. It is because over at lines. Well, let's see. 1697. String data. It's loading from a string literal. That's also gains right there, guys. Oh my gosh. We're gonna have gains if I could just solve this bug. Because all this stuff, this is at a known position in its segment. So we don't need two things here. we just go slam, dude. It's like computer vision. We just go slam. Same here. We don't need those two. We just need one. The shared memory name param is a string. Okay. Oh, that makes sense. It's a name. It's a name. So we're passing a string parameter here. I mean, I assumed that I could repro this by just passing a string literal. Let's try. Hello is sailor main. F of hello. F is S string. All right. So first let's, oh, that doesn't even work. Okay. If that doesn't even work, then who even knows about compile time execution? All right. Is this main? 6, right? That's how long sailor is. Stack plus 20. Stack plus 28. F of V1. Does V1 point at the stack? I guess. Let's see what happens if I do like a, no, let's not. Oh, this is the, yeah, argument passing. This is what we just did. Wait, V1 is just not initialized. Okay, this is a mistake. This is a mistake. I don't know how anything ran before. Because we're returning result here, which we allocated and just never said what it is. I guess we do have to Lee. Dang it. Do we still get a gain though? I think we don't get a gain. That sucks. That sucks. Okay, anyway. I thought we would get a gain. The problem is we need to return the L value in a value number. This is still better for static analysis purposes, though. Even if it doesn't lead to a better Weissman score in the short term, because like we can just see statically which allocation each of these writes to. Whereas if it's like in a variable, then you have to do further analysis. So this actually is better, and we might be able to get gains in the other ones. We'll see. All right. Really? What? How do we not do anything now? What is even going on? Okay, actually I shouldn't have done that. I admit it. So right string works. Hi S is sailor. Okay, so the x64 version is fucked up. But the compile time execution version is okay now, which means maybe we could compile the game. Yeah, so our Weissman score did not go down. And the reason is because we need to return the frickin' thing. But this is still better. It is still better. So, and I think some of those other gains may get better. But the problem now is, A, why is x64 messed up? B, I got to implement this on the LLVM backend as well. Yeah, I don't even know, like this instruction could be totally jacked. Yeah. Let's just see what instruction that well, I guess we'll see it because it's gonna probably break. Yep. Oh, Sokoban crashes right away. Let's see. Like literally no strings in the entire program work. File name not equal to double quote. Path is a string. Baker clients. Okay. So really this is the place. Okay. 1EH probably is Baker clients, right? I don't know what that is, but it's probably this. R9. Let's see what Baker clients is. I don't even know. Yeah, that's almost 32, which would be what 1E is. That's all I wanted to verify. Now, so this should be the string. where are we? Oh, it's so hard to read. So, where's our frickin' call? It's way down there. What are we doing for all this time till down there? Like, I have no idea what all this is, guys. There's probably like a rep stas and stuff. You know what? Emit string literal. I mean, we have to fix this first, but I guess we don't put string literals in our data. Anyway, okay. So we know this works. We know this works for compile time execution. Just look at all this stuff that's happening. All right. RSP plus 70H. Let's just go down there. So I think that's supposed to be the pointer to the string. Count 0, data 0. Well, congratulations. Let's try again. I'm going to go here and going to go down a bit. So, all right. Oh, whoops. I went too far. They told me I would go too far, and I didn't listen. All right. So we want to stop before this. So down there. Oh, this is all the context manipulation stuff. Down here. Is there like an IMOL and stuff? This looks like stack trace node kind of things. I don't see the IMOL though. Let me make things easy on myself. Let's just change that for now, because that emits a bunch of code that we don't necessarily want. Of course, have I turned that off in a while? No. Do I know if it works off? No. But fudge. Okay, now it doesn't like that I have an empty block or something. God damn it. All right. Let's put a NOP. that needs to get fixed later. It's not important enough to fix now, but that said, we do need to rewrite the bytecode runner officially to work with the new system. So that might just be a side effect of that we haven't done that. Okay. So silly. Maybe that's not even what's crashing it. Oh, it is. Okay, great. So now when I run it, it'll still crash. Yep. Doesn't do strings ever. But now there should be a lot less stuff. Yes, see, this call is down here. Still a lot of stuff, but not remotely as much stuff. Okay, in fact, so this R10 is probably the string pointer. Char star R10. Yes. Okay, where is that going? Nowhere. Oh no, it's going into RSP plus 42AO. We're storing a 0 for some reason on the stack. This just looks like trash to me here, guys. Like something is off. Let me just see what the dumper output is again. Oh, we don't have that. Let's dumper that. What file was that in? Make sure SVN file. Oh, Baker clients. Make sure SVN file exists. Okay, wait. We know from here. Detect and handle previous bake errors. Yeah. Okay, so we could dump this. And we will do that to an output.txt. And then we run it again. And we have this up, and then we can go to output.txt. And we know that this is fine in theory because our compile time execution works fine. Okay. OX1E. Okay. Stack plus 0 here. This being plus 4298 is probably correct because it's a different like region. Oh, that's just storing the 1E for later. Never mind. So this is, okay. Stack plus 0 is actually plus 40, which is maybe right, maybe wrong. Let's just double check that. Yeah, I guess so. I mean, it's exactly the same code. I feel like it's that move instruction is still going to be the culprit. We haven't even gotten to looking at that. Okay, so we load, that's the base of the string. We put the count, we get the data, we put the data, right? So we load, this is probably the base of the string. Yeah. Oh, yeah. So as we expect, that's count 0, data 0. Although we're saying OX50 here, which is bothering me a lot, but maybe that's a separate copy. I don't know. Okay. That's our 0. Okay. This is not right. This is not right. Duh. Duh, 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 duh. I should have just checked that immediately, because remember when I would do the thing where I pasted it a bunch? I should have just done that. Except it's not a new instruction, but this is not our dest. This is the value that we want to put. I'm so silly, guys. I'm just a silly. Sometimes I didn't need to redirect that to output. All right, well, we crash, but we crash in a different way. We don't pop up the dialog box. What does that mean? Whoa, we crashed sooner because we didn't get to our breakpoint. What is going on? Let's get rid of this. Okay. So data was OX1110, 1110, 1110, 1114. That looks like CCC. Or whatever. Oh, no, it's just a faulty error message. So this is count and data are swapped here, which seems bad. Or they're just off by 8 and there are multiple strings. How would that be if compile time execution is fully working? What about stir? That's correct. What about cares? That is not correct. Oh, well, that's a literal. All right. So R10 is this thing, which is 3 characters, I guess. Who's got the 3? Oh no, it's a backslash. It's 2 characters. Okay. So this string is at A8, right? Count to data backslash whatever. Okay. Wait, it says backslash. Oh, because we haven't written the data pointer yet. There. There we go. Boom. So that is in stack plus A8. Now, R11 is the address of something else. And this is still doing some call stuff that I kind of feel like we shouldn't be doing. Oh no, this is just loading context so that we can pass it. RAX is now some mysterious value. It's the address of somebody. Oh, the first argument, path, right? Count 22, data, whatever. Okay, great. So RAX is the address of the path guy now. We put that on the stack. RAX is now this guy. I don't think it's right. I don't know, guys. I am kind of. This is going to be something really simple, and I just can't deal. You thought the score would be lower based on conversation when you left. Yeah, depending on when you left. With the string literal so far, the thing that I thought would get gains didn't get gains, but I think there's other stuff that'll get gains. Maybe. Possibly. Like, is this is casting from string literal. I don't know why we put that on the stack. Oh, because this is for C strings right here. Yeah, this could be gains right here. Maybe not huge gains. This is definitely gains right here. Oh my gosh. This is a huge waste. Well, depends on how many C routines you call, but I want to get to those gains, but I can't because we're doing these other things that don't work. It might be time for me to take a break and go to bed and come back later because like what's happening is these stack values are just not right for some reason. And there's still too much juggling. So the problem with the x64 backend right now is whereas it has a register allocator, and that makes code terser than it used to be. That register allocator only acts on scalars. So any string or any other data structure that's more than 8 bytes, or actually any struct, just doesn't get put in registers right now. It always gets put on the stack. And because the thing that we're dealing with right now is a string, all this stack stuff is happening. So it's just kind of a maze is all. But we can work backwards. Because we know calling the function is right. That means the string is supposed to be in AO. The L value of it which is R9 up here, because, wait, that's 4.0. Oh, right there. We load R9 from 4.0, which I think is the parameter. No. So this part I think is wrong. Also, what is that? Why are we using RD9 or RDI? What the hell is RDI supposed to have in it? Nothing. Oh, except unless it's... I think it's time to bring out the knobs. Just to help us see what's going on. Double knob. double knob. Just giving ourselves a little padding right there. Okay. So those are different knobs, I think. Knob. Who's there? Okay. So what the hell is this RDI? That's just wrong. That's faulty instruction encoding or something. What is going on? I'm using the wrong... I need type safety on these guys. These are different things. I am bad at programming. Wait, it still says RDI. What's going on? Did I not recompile? Hey, look. Yeah, we need to get that type safety in there at some point, but I'm not sure how to do it in C++ in a way that doesn't suck. Hence me making mistakes like that. All right, well, I'm happy that I got that before going to bed, because honestly, I was quite close to giving up on that one. We still need to do this on LLVM. Hopefully it's easy, though. Because we do the same thing. Segment store plus offset. So we do our Aloka, we do our GEP, and then so we want to load our we want to like that, right? Unknown instructions. Still? What? Segment store plus offset. Segment load plus offset. What's the unknown instruction? Did I delete something? Oh, I ran the wrong compiler. Of course, that's been the answer to many of... Stop it! It's been the answer to many of the riddles tonight. All right. We, after running some more tests, we are going to get a second wind and try and do a little more gains. Oh boy, there's that one. Oh no! Oh wait, that's stack trace stuff though. See, okay, there's a stack trace test. But we forced, or I, the guilty party, forced stack trace to be off for debugging sanity. And yeah. Thought of adding a benchmarking library? No. Timing code can be hard to do right. Dude, the percentage of programmers in the world who need an accurate timer is like 0.000 to the nearest digit. All right. People do not need a benchmarking library. That is not the problem. Like, you just call query performance counter, dude. It's not hard. Like, yes, if you want to get very, very precise about measuring the timing of your program statistically over many runs, I mean, maybe a library could help you with that, although I kind of doubt it. But that's not people's problem. Like, almost no programmers in the world should be worried about whether their program just got 0.1% faster, because they should be making their program 90% faster. That's just where we're at. Like, it's not... The things that people need to do are so obvious when you do them. Yeah. Things like reporting port pressure, micro ops, etc. Well, the thing is, like, even vTune sucks at that. Like, I cannot use vTune to profile this compiler because it's just over, right? Like, the fastest sampling resolution vTune will do is 0.1 milliseconds, and like the whole compiler's over, right? So I don't know. Yeah, we'll see. People just want things to be done. They don't care about perf. Those people can jump off a cliff, and those people can quit programming. I mean, I don't want them to die. They can jump off a cliff into ocean water that is frigid. I'm just so tired of hearing that excuse. Because the fact is they don't even get things done. It's not like by not caring about performance they've become more productive in other dimensions. No, they just have bad performance and they still can't get anything done. So like why is this excuse bandied around? It's like okay. So that was good. That was our x64 test. We're going to do LVM test. We're back at 354545 for the Weissman score, which is still what we have on the board. That's good. Next, though, I think we get gains as soon as we can check in, which should be as soon as these finish. Didn't want to derail. Yeah. It's just also like, I think also kind of what happens is the bindings that got made in the early days were either the ones that I really needed for what I was doing, which when you're bringing up a brand new game engine in a brand new programming language, you also don't need micro benchmarking because like there's just a lot of work to be done that's more macroscopic than that. And then some of the other bindings were like just things that other people on the team did. And some of those were not even tested, which I don't think was a very good idea to put them in there. But as the beta community grows, there gets to be more bindings and stuff and more libraries written natively. So since it's a language for performance-oriented people, I would expect performance-oriented things to show up, right? So, yeah. How do you start getting into the data-oriented mindset from the perspective of a novice intermediate? I wouldn't even say that data-oriented is the important thing. Like data-oriented is kind of a buzzword. You just want to have a reality-based viewpoint about what the computer is doing when it's running your program. As long as you have that, you can solve your problems, right? As long as you understand that the computer is a machine that does certain things fast and certain other things slowly, and you pay attention to what those things are, you'll do fine, right? You don't have to put buzzwords on it. Now, the problem, of course, comes in when people in academia or people in industry tell you to program certain ways, and they say, oh, and there's no performance cost to programming this way, or the performance cost is very small, but it makes your program more understandable and maintainable. And what happens is both sides, you have to be skeptical about both sides of that equation, right? You have to be skeptical about whether the cost is as low as they claim. And you have to be skeptical about whether they're getting the benefit that they claim, right? Because again, if we've had decades of people refining their software engineering practices to get all these benefits, then where are the benefits, right? Why isn't software amazing now? It's totally not, right? And so just nobody's being reality-based about these things. Okay, this is a very good check-in. I want to do one more attempt at gains. Whatever that instruction was called. Okay, so now gains. Here I'm being very, very silly. Not there. So right here, we're saying, hey, if you need the data pointer for a string literal in order to pass it to a C procedure, do a bunch of instructions to emit the literal, and then pull out the string pointer. And it's like, no, because we know what emit literal does. This also could be gains right here. Oh, we're going to get some gains. I mean, I don't know how big, like, I don't know how many times we do this in the program. So it might not be huge, but so emit literal for a string literal. Oh, there it is. I went right past it. Oh, wait. We can pass data pointer dereference. That's a new thing. Wait, hold on. Emit literal. Literal? Null. True. That is actually all we have to do. And it's better because it doesn't do as much. Oh my gosh. That sounds good to me. Why did our Weissman score go up? How is it? What? I don't believe. So I don't believe it actually recompiled. Because it did it so fast. Okay, that's more believable. We're one instruction less somehow. It's got to be better. What? Let's test the game. Let's look at what happens in that case. If it's a data pointer dereference, we just assign to string literal and plug it. If there's a plug, do we have value placement here? We do. Let's try that. See if that helps. Yes, that was the ticket. Wait, no, now it went up. Okay, it is generally lower. We did not get amazing gains. No, we didn't get any. I don't know, guys. Okay. Okay, that wasn't really gains for some reason. String bug is squashed, yeah. There are currently no known bugs in the things that we've been doing, although there probably are some, they're just not known. The things that I've thought we're making gains, we're not making gains. Let's look at this. This thing, to-do list, this is redundant now. Initializer. I mean, why is this even here? Like, why do we have a special string case? I don't know if that'll get us gains. It probably won't. But I would like to get, yeah, it's the same code. I would like to get rid of that code, though. Super ugly. So we're making different kinds of gains right now, which is fine. So if I delete this code, like this, just, it needs to get simpler. Oh, this is still, there's a gains here. Let's try this. Oh, do placed assignment. Like, is that gonna work? Oh my God, look at all the nega gains, guys. I need to go to bed before I destroy the universe. Holy cow. Okay, we're going to revert that and go to bed. But that might give us a clue, though, because why is that so bad? It's supposed to be better. The whole reason for that function is that it's supposed to be better. So if it's not better, then what the hell? Nega gains. Yeah, we don't. Yeah, do placed assignment. So on the other hand, as I look at this, I'm like, maybe this isn't really meant for this kind of thing. The problem is the value placement stuff is supposed to be very simple, but it's actually become hard for me to think about. So I need to figure out if I can simplify that in some way. New 4-coder version is released. Maybe we'll play with that tomorrow. Although people seem pretty unanimous in thinking that I will not like it. But, okay. All right, so that was a nega gains. What about this one? Okay, the problem here is we again have this situation where we need the final address. So we need to do the Lee anyway. But maybe instead of, maybe callers could use the stack allocation. I don't know. Maybe not. Oh, yeah. Like, I think I just need to kind of keep playing with the code here and simplifying it and making it the way it wants to be. And then eventually we'll find more gains. I feel like there's a gain to be had here. So we can't actually simplify this, because the problem is we need to assign this to a value number. We could do the thing where we make it more readable. We probably should. But let's do that. Let's go segment store plus offset. -1, R value register. And BC options is big constant. So again, that's probably more readable and stuff. But it doesn't reduce the number of instructions. It doesn't reduce the number of value numbers. we could, like, if I had an extra slot on this instruction, we could actually give it a register to assign a value number to. It's just like, oh my God, it's too much at that point. At some point, it's not really worth it. All right. This will not affect our Weissman score. We're kind of spoiled with the early gains. Well, there will be more gains. I have maybe some big gains up my sleeve, although you never know. Sometimes the gains are much harder to come by. You know, I have 2 items on this piece of paper, either of which could be quite large sources of gains. Maybe I'll start doing one of those. What if we just start working on, and maybe I'm not going to do it all the way, but like, hey, I got to stay awake. My girlfriend's coming over. Let's just try to do a little bit. And if it's a disaster, then it's a disaster. Okay. Update notes. Okay. Now what? Yes. We, in basic block, this is actually a technical term. We're going to go previous and I don't know if I need this instruction index. Let's just call it. Do I need the instruction index? I don't know. You know what? I'm too tired to do this right now. No, I'm going to get third wind. Third wind. We're going to do it. How many hours are we into the stream? We're 4 hours in. I streamed for 5.5 hours before. So that's 9.5 hours of streaming, probably. Maybe more. Plus the time I worked off stream. It's a lot of time. Full-time streamer. Full-time streamer. Okay. More tea needed. Well, I do want to be able to go to sleep, is the problem. I do want that. So for basic blocks, there's this thing called the dominating set, whatever. People are overly mathematical about it, but basically, it's the blocks you had to go through to get where you are. And rather than computing this by weirdo analysis, we're just going to build it as it happens. And the reason I want an instruction index is because people can have branched out of a block. So if I want to know if something's valid, yeah, I guess I need that. Let's just start doing it and we'll see. Because we can start, because I'm not very serious about making this work tonight. We just have to search for dominating. Okay. So for loop, great. We're doing one of the hardest ones right away. Emit for. So we go loop top basic block. Do we have predecessor? Yes. So we're going to say we could actually have a dominating flag here. Wait a minute. No, loop top basic block is not. We're going to say predecessor is dominating. Iterator basic block. Predecessor is dominating. Actually, I'm a little tired to think about this correctly. The iterator basic block is at the bottom of the body. So we did have to go through that. No, we did have to go through loop top basic block. So why do we not put this here? Oh, because we don't finish it? I don't freaking know. Okay, guys, I gotta go. I'll see you later on when I'm thinking more clearly about this. Thank you for coming by. We will do more of these things soon. Probably need a pre-header basic block for loops. Yeah, I don't exactly know. We'll see. Bye, everybody.